Think about the last plant you lost, not the ones that just faded quietly at the end of their season, the ones you actually tried to save, the ones where you watered more or less, or moved them to a different spot, or added fertilizer, or did everything you could think of and still watched them decline. Now think about this. What if the thing you tried was the exact opposite of what the plant needed? What if the extra water you gave the wilting plant was the thing that finished it? What if the fertilizer you added to the yellowing leaves made the root problem worse? What if you were responding to the symptom and not the cause? This is the central problem in plant care that nobody talks about directly. Plants get sick in completely different ways. A plant dying from too much water looks almost identical to a plant dying from too little. A plant suffering from a fungal infection looks almost identical to a plant suffering from a nutrient deficiency. And the treatments are not just different, they are opposite. Giving the wrong treatment to a sick plant is not neutral, it accelerates the decline. Today I'm going to walk you through every major category of plant illness, what it is, how it works biologically, exactly how to identify which type of sickness you are looking at, and the specific recovery method that addresses the actual cause rather than just the visible symptoms. 7 categories of plant illness, everyone explained completely. Everyone with a clear, actionable recovery protocol that you can apply the same day you identify the problem. And I want to be honest about something before we start. Some plants cannot be saved. Category 7 covers the illnesses where the correct answer is to remove the plant, rather than try to recover it. And knowing when to do that is as important as knowing how to treat the ones that can come back. By the end of this, you will not just recognize that something is wrong with your plant. You will know what is wrong, why it is wrong, and exactly what to do about it in the right order. Let us get into Category 1. Category 1 is root stress, and this is the master category that underlies most plant illness in containers and in-ground plantings alike. Almost everything that goes wrong visibly above the soil surface starts with something going wrong at the root level. Understanding root stress is the foundation of understanding plant health. Root stress comes in 2 primary forms that look nearly identical from above: overwatering root damage and underwatering root damage. Both produce yellowing leaves. Both produce wilting. Both can produce brown tips and dropped foliage. The difference is in the soil and in the roots themselves. Overwatering root damage occurs when the root zone stays wet for extended periods. Roots need oxygen as much as they need water. Soil that stays saturated displaces the oxygen that healthy root function requires, and roots begin to suffocate and decay. As the root system deteriorates, its ability to transport water and nutrients upward collapses, and the plant above shows every symptom of drought even though the soil is wet. This is the trap that catches most gardeners. The plant wilts. They water more. The additional water makes the root decay worse. The plant declines faster. They water more again. By the time the pattern is identified, the root system may be severely compromised. The diagnostic test for overwatering root damage is simple and definitive. Push your finger 2 inches into the soil. If the soil feels wet or even consistently cool and damp, the problem is overwatering. Carefully lift the plant from its container or gently excavate around the root ball in ground plantings. Healthy roots are white or light tan and firm. Damaged roots are brown to black and soft or mushy. The presence of mushy roots combined with wet soil confirms overwatering root damage. Recovery protocol for overwatering root damage. Stop all watering immediately. Remove the plant from its container. Use clean scissors to trim away every root that is brown, black, soft, or has a foul odor. Trim generously. Leaving damaged root tissue increases the risk of the rot spreading to remaining healthy roots. Dust all cut surfaces with powdered cinnamon, which has natural antifungal properties, or a commercial powdered fungicide. Let the root ball sit exposed to air for 1 to 2 hours. Repot in completely fresh, dry, well-draining mix with 30% coarse perlite. Do not water for 48 hours after repotting. The plant will look worse before it looks better. Give it 2 to 3 weeks. Underwatering root damage is less destructive in most cases but creates its own cascade of problems. When soil dries completely and repeatedly, root tip cells die. The finer root structures that are most efficient at water and nutrient absorption are lost. The plant compensates by reducing leaf surface area, dropping leaves and halting growth. But if the drought stress continues long enough, the damage accumulates to the point where recovery requires significant time, even after proper watering is restored. The diagnostic test is equally simple: dry, powdery, or cracked soil surface, soil that has pulled away from the container edges. Extremely lightweight container. Bone-dry soil at 2 inches depth. Water that runs through the container almost instantly without absorbing, which indicates hydrophobic soil that has become water repellent from extended dryness. Recovery protocol for underwatering. For hydrophobic container soil, set the entire container in a basin of room temperature water for 30 to 60 minutes. Allow the soil to rehydrate from below. The soil will visibly absorb water and the container will become noticeably heavier. Remove from the basin and allow full drainage before resuming normal watering. For in-ground plantings, water slowly and deeply at the base of the plant, allowing the water to penetrate the full root zone rather than running off the surface. Mulch 2 to 3 inches deep around the base to retain future moisture. Do not fertilize until the plant has shown clear signs of recovery, because fertilizer applied to stressed roots increases osmotic pressure and makes water uptake harder rather than easier. Category 2 is nutrient imbalance, and this category encompasses both deficiency and excess, both of which cause visible symptoms that are frequently misdiagnosed as watering problems. The most important thing to understand about nutrient imbalance is that the symptom pattern is diagnostic. Different deficiencies produce different identifiable visual patterns, and reading those patterns correctly leads you to the right correction. Nitrogen deficiency produces uniform yellowing that begins in the oldest, lowest leaves and progresses upward. The yellowing is even across the entire leaf, not patterned or spotted. Growth slows noticeably. New leaves emerge smaller and paler than normal. Nitrogen is a mobile nutrient, meaning the plant can relocate it from older tissue to newer tissue when supplies are limited, which is why the yellowing starts at the bottom. Recovery is straightforward. A balanced liquid fertilizer or a fish emulsion application delivers available nitrogen quickly. Follow with a slow-release granular fertilizer for sustained supply. Iron deficiency, called iron chlorosis, produces a very different pattern. The newest, youngest leaves yellow first while the veins remain distinctly green, creating a striking green-veined yellow leaf that is almost unmistakable once you know what you're looking for. Iron deficiency in the soil is rare. Iron chlorosis usually occurs because the soil pH is too high, making iron chemically unavailable to roots even when it is physically present. A soil pH test is the first step. If pH is above 7.00, acidifying amendments like sulfur, acidic mulch such as pine bark, or aluminum sulfate lower pH and restore iron availability. An iron chelate foliar spray provides immediate visible improvement, while the soil amendment takes effect. Potassium deficiency produces browning at the leaf tips and margins that progresses inward on otherwise green leaves. Older leaves are affected first. Potassium is essential for water regulation within the plant and for disease resistance. Deficiency makes plants more susceptible to both drought stress and fungal infections simultaneously. A fertilizer with higher potassium content, such as a bloom booster formula with elevated phosphorus and potassium relative to nitrogen, corrects the deficiency over 2 to 3 weeks. Nitrogen excess, which is as common as deficiency and far more destructive in flowering plants, produces lush, dark green, abundantly leafy growth with dramatically reduced or completely absent flower production. The plant looks healthy and vigorous by most measures but refuses to bloom. The excess nitrogen is driving vegetative growth at the direct expense of reproductive growth. Stop all nitrogen-heavy fertilization immediately. Flush the container soil with clean water to remove accumulated nitrogen salts. Switch to a low-nitrogen, high-phosphorus bloom booster formula and wait 3 to 4 weeks for the nutritional balance to shift toward flowering. Category 3 is fungal disease, which encompasses several distinct conditions that gardeners frequently confuse with each other. Each has a specific appearance and a specific treatment, and treating one fungal condition with the remedies for another wastes time the plant may not have. Powdery mildew appears as a white, powdery, superficial coating on the upper surface of leaves. It looks like the leaves have been dusted with flour. Powdery mildew is caused by airborne fungal spores that thrive in warm days combined with cool nights. It does not require wet leaves to establish, which surprises most gardeners who assume it is a moisture problem. It spreads rapidly through the air and can move across an entire garden quickly once established on one plant. Remove the most heavily affected leaves. Improve air circulation around the plant by removing crowded neighboring plants if possible. Apply a solution of 1 tablespoon baking soda dissolved in 1 gallon of water with a few drops of liquid dish soap as a surfactant, applied to all remaining foliage. Repeat every 5 to 7 days. A neem oil spray at the labeled dilution is equally effective and provides residual protection. Do not use overhead watering on affected plants for the remainder of the season. Root rot is a fungal condition that begins underground and is rarely visible until it has progressed significantly. Phytophthora and Pythium are the most common culprits in overwatered containers and poorly draining ground plantings. The plant wilts despite adequate soil moisture. Leaves yellow from the bottom up. The crown of the plant at the soil line may show discoloration or soft tissue. When excavated, the roots show brown to black discoloration and mushy texture. Recovery overlaps with the overwatering protocol above, because overwatering creates the conditions that allow root rot fungi to establish. Trim all affected roots. Treat cut surfaces with fungicide. Replant in fresh, well-draining mix. A soil drench with a copper-based fungicide or a biological control product containing Trichoderma species adds a layer of protection during recovery. Crown rot is a specific and often fatal fungal condition where the decay occurs at the crown of the plant, the point where stems meet the root system. Plants affected by crown rot collapse suddenly, and the crown tissue feels soft when pressed gently. The stems at the soil line appear water-soaked or dark. This is a genuine emergency. Remove the plant from the soil immediately. Cut away all soft, discolored crown tissue with sterilized scissors. If any firm, healthy tissue remains at the crown, dust with fungicide and attempt to root the remaining healthy stems as cuttings. The original root system is almost certainly unrecoverable. Prevention is the most important strategy. Never allow mulch or soil to pile against the crown of a plant. Maintain good air circulation around plant bases. Avoid overhead watering. Category 4 is bacterial infection, which is less common than fungal disease but progresses faster and is generally less treatable once established. Bacterial infections in plants enter through wounds, damaged tissue, or natural openings in the leaf surface during wet conditions. The symptoms differ from fungal disease in important ways. Bacterial infections tend to produce water-soaked, translucent lesions that expand rapidly, often with a yellow halo at the expanding margin. The tissue inside the lesion collapses and dies quickly. The damage can spread visibly from day to day. Affected tissue often has a foul odor. There is no effective chemical treatment for established bacterial infections the way there is for fungal conditions. The recovery protocol is entirely mechanical. Remove all infected tissue immediately using sterilized cutting tools. Sterilize between each cut by dipping the blades in a solution of 10% household bleach. Remove generously, cutting into clearly healthy tissue well beyond the visible margin of infection. Bag and dispose of all removed tissue. Do not compost it. Improve air circulation and drainage. Avoid all overhead watering. Copper-based sprays applied to surrounding healthy tissue can reduce the spread of bacterial infection to unaffected parts of the plant. Category 5 is pest damage, which produces symptoms that are frequently confused with disease or nutrient problems, because the pests themselves are often invisible or overlooked. The recovery protocol depends entirely on correctly identifying the pest. Spider mites are the most common and most damaging small pest of container plants in hot, dry conditions. They are too small to see clearly with the naked eye, but their damage is unmistakable. A fine stippling of tiny pale dots across the leaf surface gives the whole leaf a grayish, dusty, or bronzed appearance. Fine webbing on the undersides of leaves and at stem junctions confirms spider mites. They thrive in hot, dry conditions and populations can explode within days in peak summer heat. Recovery protocol. Increase humidity around the affected plant. Apply a forceful spray of water to all leaf surfaces, particularly undersides, every 2 to 3 days for 2 weeks. This physically dislodges mites and disrupts reproduction. For severe infestations, insecticidal soap or neem oil applied to all leaf surfaces, including undersides, every 5 to 7 days provides effective control. Aphids colonize new growth, congregating on the undergrowing parts of soft stem tips and young leaves. They are visible to the naked eye as small green, black, or white soft-bodied insects clustered in groups. They cause distorted new growth, sticky residue on leaves and surfaces below the plant called honeydew, and eventually sooty mold, a black fungal growth that establishes on the honeydew. A forceful water spray directed at aphid colonies removes them effectively in mild infestations. Insecticidal soap spray is the next level of intervention for heavier populations. Introducing or encouraging natural predators like ladybugs and lacewings provides biological control that is effective and sustainable over time. Category 6 is environmental stress, which covers the range of physical and atmospheric conditions that damage plants without any pathogen or pest involvement. Sun scald appears as bleached, papery, often white or tan patches on leaves that were exposed to sudden, intense sun after a period in lower light. It is common when plants are moved from shade to sun too rapidly, from indoors to outdoors in spring, or from a protected to an exposed location. Affected tissue does not recover, but the plant usually survives and produces new growth adapted to the higher light level. No treatment other than preventing further scald by gradually acclimating plants to new light conditions. Frost damage produces blackened, water-soaked tissue that collapses and dries. Do not remove frost-damaged tissue immediately. Wait until the threat of further frost has passed and new growth begins from the base, then remove all dead material. Some plants that appear completely dead after a hard frost regrow vigorously from the root system in spring. The root system below the frost line often survives when all above-ground tissue has been killed. Chemical burn from fertilizer applied too heavily, too frequently, or to dry soil produces brown, scorched leaf edges that spread inward from the margins. It can resemble potassium deficiency, but progresses faster and is often more uniformly distributed across the plant. The recovery protocol is to flush the container soil or ground around the plant with large amounts of clean water to dilute and remove the excess fertilizer salts. Withhold all further fertilization for at least 4 to 6 weeks. Category 7 is systemic disease, which is the category that plants rarely recover from, and that gardeners need to recognize in order to make the difficult decision to remove a plant, rather than spend time and resources attempting a recovery that will not come. Viral infections in plants are incurable. They are transmitted by insects, particularly aphids, and by contaminated cutting tools. Symptoms include mosaic patterns on leaves, which is a patchwork of normal green interspersed with pale yellow or light green areas in an irregular, non-uniform pattern, as well as distorted new growth, stunted overall habit, and in some cases ring spot patterns on leaves or fruit. A plant showing mosaic virus symptoms will not recover. Remove it. Sterilize all tools used near it. Control aphid populations aggressively on surrounding plants to prevent spread. Verticillium and Fusarium wilts are soil-borne fungal diseases that attack the vascular system of plants, blocking the internal transport of water and nutrients and causing progressive wilting from the branch tips downward regardless of soil moisture. Cutting a stem from an affected plant often reveals discoloration inside the stem tissue itself, brown or black staining within the vascular ring visible in cross-section. There is no recovery from advanced verticillium or fusarium wilt. Remove the affected plant. Do not replant susceptible species in the same soil for several years. Solarizing the soil by covering it with clear plastic during summer heat for 6 to 8 weeks kills some but not all of the soil-borne pathogens. Here is what ties all 7 categories together. Every plant illness is a failure of something in the plant's environment to match what the plant needs. Not a failure of the plant, not a lack of green thumb, not bad luck. A specific mismatch between conditions and requirements that has a specific cause, a specific identification method, and a specific recovery protocol. Most of the time, that mismatch is completely correctable if you catch it early and respond to the right cause. The gardeners who save the most plants are not the ones who act fastest. They are the ones who identify correctly before they act at all. A week of careful diagnosis followed by correct treatment saves more plants than a week of aggressive intervention based on a wrong assumption. Slow down. Look at the whole plant. Check the roots. Test the soil. Identify the category. Then apply the right protocol in the right order. That sequence, practiced consistently, is the difference between a garden that recovers and one that simply teaches you what not to do again. Give this a thumbs up if it helped you think differently about a plant that is struggling right now. Drop a comment telling me which category matches what you are seeing in your garden and what plant it is affecting. I read every comment and I respond to as many as I can. Subscribe for practical science-based gardening content every single week. Now go look at your plants with new eyes.